Hello everyone. In this video, I'm going to explain why do we need hypothesis testing for. So let's assume that we have a big jar and there we have number of white balls and the black balls. Let's assume that the number of balls, total number of balls is not much, maybe 20 to 25. So now if I ask you the question that can you tell me is the white balls greater than the black balls or the black balls greater than the white balls? So what we can do is that we can simply take out each ball and count them, and we can easily understand that what is is the white balls greater than the black balls or not. But what if the sample or the jar had multiple balls? I mean, maybe in thousands of black and white balls. How could we do that? Of course, we could count it, but it would take a long time, and that is where statistics comes in. That is where statistics comes in as a understanding of the data without delving into each data point. So in that case, what we need to do is that instead of counting all the number of balls, we need to take samples from it. So let's take the first sample. So the first sample is maybe we have lost in the first sample 3 white balls and 2 black balls, and the second sample we have got 4 white balls and 1 black ball. So, and in the actual case, which is not known to me, let's assume that it is not known to me. Let's assume that the number of white balls is greater than black balls in this case. But I don't know I don't know this result when I'm doing the sampling. What hypothesis testing tells us that whether the sample that I've got is representative of the population by chance or by luck or not. That means, have I got, so if the question is the number of white balls greater than the black balls, so from this sample we can understand yes, because we have got 3 white balls and 2 black balls, probably it is probably we can say that maybe white balls are greater than the black balls, which is true for this case. So what hypothesis testing tells us is that it's not sure that it's going to be white balls greater than black balls, but it can give you a chance that this sample, or it can give you the chances that probably that this sample is representative of the jar in the big jar, or probably not, and that cutoff or that probability is calculated by the p-value. What is the p-value? P-value is nothing but a cutoff value which is standardized for different cases according to the threshold and X research. If it qualifies, if it's greater than the p-value, maybe we can consider that maybe the sample that we have got is actually by chance, and maybe it may not be the same. If the p-value is very high, then probably we can understand that we have got a correct sample by chance. Maybe it's not the case because the p-value is higher. You can assume it to be a probability value, so maybe that I got it by luck. It might not be true, and otherwise it might be true. If it's less, if the p-value, if the value that we're getting is less than the p-value, then probably it is less. So that is, so what hypothesis tells us is the probability that the sample is representative of the population by sheer luck or not. Thank you.